We'll share some things. I'll ask some questions, and let's see how it rolls. Um, I think we can also feel free. We just went live on Twitter right now under, I think, my username, which is Itamar underscore Mar, and you can share it or whatever. Should I do anything? Okay. You can share it so other people can join. I would say also on LinkedIn, but I think everybody here is on Twitter, right? Right. Okay. I guess like the managers are on LinkedIn and makers are on Twitter, right? Okay. Cool. Okay. So I think we're good to go. I think you can share a screen, Toran.
Brilliant.
We hear you.
That's good. It's great to be here virtually. I wish I was in person.
You're on the entire screen, so don't worry. It feels like you're here.
Brilliant.
Good.
I didn't realize Codium was so big.
Life size. Okay, how's that?
Yeah, we see quite well.
Yep, is that good?
Yep.
Okay. So let's talk about the future of work. Big topic. Yeah, so first, if you don't know what AutoGPT is, bit of background. You can think of it as an agent that uses a large language model as its brain. It's best thought of as a user sitting at a computer. It has its own thoughts, it makes its own plans, and interacts with the system based on its own goals.
So I have a question, Toran, just before you skip. I'm not sure everybody are aware or know, but I think many people wanted to ask, what can you share more about octopus? What's the thinking behind it?
Yeah, no one's actually asked me this before. I was inspired by a book by Peter Godfrey Smith called Other Minds. And if you've not read this book, I highly recommend it. It talks about octopuses and cephalopods and how they are such an intelligent creature, but so completely different to anything that we can imagine. You know, their nervous system is throughout their whole body. They almost have multiple brains. You know, their arms are almost like AI agents that communicate with the brain and the head. And yeah, the author of this book says that, you know, these creatures are the closest we may ever come to studying, you know, an intelligent alien. And I think this is also very, very appropriate for AI as well. You can see.
Cool. Thanks for sharing.
Yeah. I first released AutoGPT in March. On April Fool's Day, I posted this video on Twitter of it running through just a simple Python script that I'd created some mistakes in using AI, using LLMs. Yeah, I'll give you a watch if you haven't seen it before.
Reading the basicmath.py file to evaluate and improve it. Evaluating the code for syntax errors and logic issues. Improving the code based on the evaluation suggestions. Writing tests for the functions in basicmath.py. Appending the tests to the basicmath.py file. Executing the basicmath.py file to test the code. Fixing the syntax issue with the calc_circumference function. Saving the updated code and tests to the basicmath.py file. executing the updated basicmath.py file to test the code. The code in basicmath.py has been successfully evaluated, improved, and tested. The task is now complete.
So Toran, I'm curious, like, why did you choose this specific demo? And also about, I think you're using like 11 labs.
Yeah.
Like, what brought you to use that? Like, I guess it was part of the vibe of the video, and I'd love to hear your thoughts about these two.
Yeah, 11 Labs I started using myself when I was I'd made this AI newsletter, AI generated newsletter to like keep up to date with the latest AI news. This is kind of where AutoGPT actually originally came from, and I was playing about the idea of an AI generated podcast. You know, you could take this so far and have, you know, everyone having personal podcasts and things like this. You know, playing about that, and found 11 Labs, and they're super cool, really realistic, especially for like narration and like audiobook type things. It's incredible.
Got it.
Yeah. This specific test, I mean, you know, I'm a programmer, games developer. I thought it's a, you know, it's like one of the final challenges, I would say. I mean, this is obviously very, very basic, but this is one of the final challenges for AI, is like to comprehend and understand like how programming works. It's such like a large, you know, high level overview is required. It's such a large task. You know, with loads of different steps. This really kind of shows its thought process, its self-criticism, seeing it makes mistakes and seeing how to fix them. So it's a good way to demonstrate that.
Got it.
So, what's next for AutoGPT? So, the core vision for this project, the reason that I open sourced it and wanted to make this available to everyone, is the fact that, you know, this is a really, really powerful technology, and there's no doubt it's going to completely change the future of humanity. If this technology was developed, like something like AutoGPT was developed by a big corporation, you can see the logical next step would be to automate away all of their work and replace all their employees. And they wouldn't want to release that, because they would lose their advantage. Wouldn't make sense. So the vision behind this has always been to try and level that playing field, give everyone access to this technology, and allow everyone to reap the benefits. But up until now, this has not really been the case. AutoGPT is loved by programmers, but, you know, to be able to actually run it, you have to install Git, clone the repository, you know how to use Python, or at least set it up on your computer and run it through a command line, which is pretty crazy. So the solution to that is a web interface, desktop applications, and later on mobile applications. So first look at what we've been working on. We want to make something really non-technical. We'll probably go through loads of iterations of this, because, you know, whenever programmers work on something, it's always too technical. It's so difficult to think like, you know, what would my mother be able to use? And this is a core focus. We'll always be coming back to that, so everyone is equally at an advantage.
Can you share a bit like about the thinking behind this web interface? Like if you can go for one or two examples or parts, or what was important in designing it, anything you like to share about the thinking behind building this interface?
Yeah. I mean, there's so much to it. You know, we're distilling down a very complex process. Like if you've used the command line interface, you've seen that demo, there's a load of information, and it's all really cool information. Like if you're a bit of a nerd like me, you look at that and be like, oh yeah, I want all of that. But, you know, the user, the everyday person doesn't want all of that. So deciding like what information is key and allowing an advanced user to drill down into the juicy bit is really key here. So we've tried to, you know, follow that ethos in everything. We've got these cards in the middle. You can actually see it better down here, where you've got the thoughts. You know, you can just have something like this that says it's thinking, or you can click on an arrow and expand down and find out exactly what it's thinking and why it's thinking that. You have a Google search you can see roughly what it's doing, but you can drill down and see, okay, it's gone to this website, it's seen these really specific results if you want it.
Cool, got it.
Yep. And yeah, mobile app, similar frame.
So this is exciting. Basically, you're saying that you want to enable anyone from whether mobile or web to be able to call AutoGPT and be able to see also all the processes that's happening, similar to how developer would see it from the command line until today, something like that, right?
Exactly. Yeah, if they want to, but they don't need to. That's the important thing. You know, you shouldn't need to get technical to be able to use an AI agent. I want a child to be able to use it. Like,
Okay.
it should. If a kid wants to be able to make a video game, why not? Let them do it. You know, this would be a wonderful feature.
Got it.
And so, yeah, moving on to plugins. So, plugins can be thought of as abilities for AutoGPT. These are, if AutoGPT is the user, not the computer, then an ability or a plugin is the software installed. Or, you know, that could be something very simple, but it could be a really advanced software. That software could use AI. Think of, you know, Photoshop that has, you know, intelligent algorithms built into it and big processes taking part. Here you can see on Discord all of the amazing plugins people are working on. There's so many, and it's so great to see.
Yeah, that's amazing. I also spend a lot of time in the Discord and see what people are working on. And I have to say, at this point, like it really raises the question: is AutoGPT basically competing with ChatGPT? Because we're talking about the web interface, the mobile interface, plugins, and I like to pick your brain about that.
It's a very good question. I love this question. You can, if you think of this scenario with ChatGPT with plugins, then AutoGPT is kind of another layer on top of that. AutoGPT is the user using ChatGPT with these plugins. You know, it's the decision maker, and it could just be sitting down using this for hours in the same way a person would be. So it's that extra layer on top.
So would you say, like, would it be like kind of accurate to say that you expect AutoGPT to be more autonomous?
Yeah, exactly. Autonomous and planning, and, you know, executing a series of steps in a plan, not just carrying out a task.
Okay, I guess that raises a lot of other questions, but I guess we have plenty of time later, and people can ask maybe later on. Cool. Let's keep on.
And so, again, getting back to accessibility, currently plugins are GitHub repositories. That's not good. So, solution to that is an abilities hub, something built into the user interface, super easy, just plug and play, select the things that you want. And plugins can be developed by the community and by businesses. We've had, you know, a lot of interest from different businesses that provide brilliant solutions to different things, and you know, lots of people want to build things for this platform, and it's great. Yeah. Okay. So, very big topic, efficacy. So efficacy is the ability to produce a desired or intended result. Very important for an AI agent to be able to do this. Quite a lot of debate online as to whether this is possible, which is very interesting, very exciting to me. At the moment, here are some of the mistakes that AutoGPT can make. You can get stuck in a loop. You know, it can use placeholders instead of actually what it meant, or just making just really obviously silly decisions. Now, I can think of so many different ways of solving this problem. I'm sure many of you here today can think of far better solutions to these problems. But the question is, how do we know what is the right solution? What is objectively best? You know, do I just test it out and run it 100 times? Or, you know, how do I actually know? And the solution to that we're working on is challenge-driven development. So this is kind of like test-driven development for the future. Instead of, I mean, like, so the way this works is defining things that AutoGPT currently can't do? What does it currently trip and fall down on? What things is it just terrible at? Defining all of these things in a programmatic and objective way and writing a test for them that we know it fails is an amazing step towards solving them. Because once you've got that, you can apply all of this amazing energy we've seen from the tens of thousands of developers who have joined the Discord and all these people wanting to take part. They can try out their novel ideas and solutions, even if it's like so different to what I'm thinking or what someone else involved in the project is thinking. Even if you're not a programmer, you can come to the table with just this novel idea of how maybe prompt engineering should work, or even what it means to write a test. It's every single topic you can dig so far down into here.
So if I may say, like for me, it really resonates well. So I think like in software development 1.0, you could do TDD, like test-driven development, probably a good practice, but really hard to really practice it, and we're going to talk about a bit later. And then in software 2.0, when you have like machine learning, neural networks, etc. Specifically, I'm not saying LLM because I'm talking about like a few years ago and intentionally. Then you can't work without like data set driven development. You need statistical models. You have to work with some data set like a training set, a validation set, a test set, and according to that, you try to understand if you're progressing or not. And it's very good, by the way, if you have a few variables or a few metrics that you're using to not only one to verify your model properties and behavior. And then like in software 3.0, then it's also statistical models, etc. So now we're evolving from 1.0 TDD, 2.0 is like data set driven development, and now we're talking about 3.0. What you're saying is challenges driven development, right? I think it's for me it's a great notion.
Yeah, it's really exciting. I think people all over the world want to take part in something which is defining the future of our species, and this is a great way to do that.
Awesome.
Yeah, so an exciting one is self-improvement. Now there's so much to talk about here. Lots of safety, lots of ethics. But to keep it simple, the first ever pull request on AutoGPT, if you look it up, it was actually by AutoGPT. The early version of it, it rewrote the entire prompt that it used, that I'd written. You threw that completely away, wrote a way better one. And we still largely use that today. This was obviously a very simple self-improvement task, a little bit of prompt engineering, but you can quickly see how this could become very, very powerful in the future, iterating over the code base and using those improvements to make further improvements.
So I guess like a question I can ask here, like, is it like it doesn't work and then suddenly it works, and then from there on we're done? Like AutoGPT will start improving itself, and we can do just set aside and start using the web interface or the mobile interface, and anything that doesn't work, AutoGPT will fix. So I wonder if it's like you expect it to be not working, and then suddenly self-improvement is working, and that's it? Or are there any levels, or similar to the challenge-driven development, maybe there will be like also levels in the challenges? Maybe the challenge of self-improvement also have some levels. I wonder how you think about it.
Yeah, no, it's a very good question. I mean, yes, maybe there will be this moment where suddenly everything changes. But in terms of like what's happening right now, it's very easy for you to take a single method or a file or a prompt, and get it to re-engineer something like that. And again, it comes back to, especially with prompts, what's objectively better. We don't know what's objectively better, and neither does AutoGPT. So that's why these challenges are so important, and regression tests as well. If AutoGPT makes a change to itself, it can get feedback on that and say, okay, I actually broke something, or, oh, now I'm able to remember better. This is great.
Got it. So maybe another look at it is maybe there are like a few dimensions of self-improvement, or the capabilities of AutoGPT managing to work on code, or or on itself on its own repo. For example, maybe like one dimension is how much, what is the context? Is it able to work on the entire repo at the same time, or on this other dimension, what is it improving? For example, let's take a relatively easy task, everything is relative, of changing the variable names to be more clear or according to some best practice. Maybe then like asking AutoGPT to fix or improve for the entire repo at the same time with some chain of thought or everything that we know about agents, and we're going to talk about a bit later. So asking to change the entire, fixing the entire variable names or so, maybe that will work. And then maybe there are other tasks and that dimension. And I guess like it's not going to be like 0 to 1. Rather, like if we think about just these two dimensions, then some of these cubes in the 2 dimension going to be solved one by one until suddenly like this two dimension, there's enough of these cubes that are solved, and suddenly maybe we can solve everything. Like it'll be like a huge self-improvement. I'm just like suggesting a thinking framework.
Mm-hmm. Yeah, there's so much to think about with this. I mean, you know, that example I showed you with the single file of code being iterated on is like, you know, it's so exciting to watch. You know, I was so excited when I first saw that. But it's, you know, it's not really programming, because you have to have this like high level overview. You have to understand, like, if I change this variable name, you know, that's in 6 other files. They need to be connected. If I call this function, I need to get the right, you know, data types back. But this is a solvable problem. Like, I've played about with it. I know I've spoken to other people who have. You know, we will very soon, I think, have a system where something like AutoGPT can iterate over a large code base and make meaningful changes that work.
Cool. So we can go back to this if others have will have a question later. Let's move on.
Okay. And finally, yeah, so touched on this a bit before, but this is very, very important. We're on the cusp of entering a new age for humanity with amazing benefits. You know, productivity and individual ability is going to skyrocket, but that's only a good thing if everyone gets that benefit. If some people are left behind because they didn't, you know, they're not very technical, they don't really know how to use computers or program or whatever it is, we'll end up in a worse world than the one we started with. So it's a big focus of us to make sure the project is easily usable by everyone. You know, the first step to that is what I've touched on before. You know, making a user interface. Don't use the command line interface. You know, something people can actually use. But you know, a much more interesting one is prompt engineering. Prompt engineering is prevalent in society right now. Everyone is starting to use it. People that don't know how to use computers or, you know, don't know how to program are using it. But it's not intuitive. Like, you have to, especially for things like, you know, image generation, if you've done that, you've got to be so specific to get something good. And people are working on this problem in amazing ways. But, you know, when we first made AutoGPT, you had to input the name, you had to give it a, you know, couple of sentences for like its role, and then 5 sentences for all the goals that it has to do, and probably in some technically accurate way. And, you know, that was a terrible experience. And it's unnecessary, because large language models, they can prompt themselves. This is what AutoGPT essentially is. So, you know, we added an extra layer on top of that, and now you can say, write a vegan cookbook, make me Flappy Bird, and it will decide how best to prompt itself. Yeah. It's not down to the user.
That's awesome. So I think we'll just, if someone has maybe one question, because we're going to do like a Q&A session, but maybe someone really have some, can't wait. Is there anyone like that want to ask one question?
What's a good response to people who see AutoGPT and immediately just think of like evil AI taking over? I've talked to friends about this, and some of their responses have been really negative, and I don't have a good optimistic answer for them.
Yeah. I think, is my microphone also on? It's okay?
Yeah,
like, for example, Torren, can you hear me?
I can see.
Yeah, so I think like this usually when I start talking to people about that, it takes between half an hour to many hours, because it's really a question that can be viewed from many directions. Um, there are different technologies that can be used in many ways, and is it like a question about if people could use AI evilly or AI is going to use AI evilly, and so it's really like I think a really broad question, and I think it would be a good one when we're getting a bit tired at the end of the hackathon, and the beer is over there. Okay. Okay, so we'll keep the Q&A later. We'll have a longer session. I just want to have anybody who had like a question that must ask. And now I'm going to share. Thank you, Toran, very much.
Pleasure.
Of course, stay with us. Hide video panel, right? And hide floating meeting. Okay, Toran, I'll use you, the guinea pig, to verify that everything works well. Do you see the screen?
Yep, I see it, and I hear you loud and clear.
Thank you. So we're going to talk a bit about agents and actually talk about just one use case. I don't want to be too long, but actually the use case is a class of use cases because we're going to talk about software development, using agent in software development, and I think there are so many use cases over there, and I see in front of me like a really amazing group of people that probably working on different angles of this use case. And so I'm expecting like really cool discussion later on. But let's start with agents. I'm gonna do it really simple. Like I hope I manage to make it like agents for dummy or something like that, but really simple. Agent GPT or agent LLM, because there are also other kinds of agent, like one that running in your server, etc. So agent LLM or so refers to an autonomous AI-based program. Okay, that's I think the first part, capable of interacting with configurable environment. Okay, well, that's what we hope. That's part of the suggestion here for you, and tools to complete requested tasks. Okay, that's like how we see it. We're gonna go back to like a really high level architecture in a second, but first I want to explore different aspects of agents. So first, like an agent could be a single agent. It could be many agents working together. When you think about many agents working together, it could be like a super agent, a main agent, or something like that, coordinating a few other agents working together, right? Or it just could be like an agent, a swarm or so. Another dimension we can think about is like agent generic versus specialized. Let's take the very specific case where we have many agents, and you could have a super agent. Sorry, the case where the case where there's a super agent and additional agents. Let's focus just on that for a second. So when we're considering generic versus specialized, we can think about a super agent with additional generic agents. In my opinion, this is roughly what's going on right now in AutoGPT. Or we can think about super agent that actually utilize a few or many specialized agents. And what are these specific agents and why are they different from each other? I think that when we're going to talk about the software development case, we might shed some light on and see that there might be different specialization. It could be from different integrations. It could be because of different data that each one has was exposed or is exposed at a given moment. Okay. Now this is the most simple diagram I could think about. Really, like I try to simplify as much as I can. Really dumb simple of what is agent in general. And I think like the agent is basically, it's a core algorithm that can think, rethink, reflect, use tools, decide, criticize, and basically it uses different type of tools, and the tools opens a new dimension, like the environment. Each tool also brings a different environment. Like if it's a tool that enables you to browse the internet, and this tool will expose you to, you know, a larger environment, etc. And then there's the memory. We could put the memory inside the tool, but I think like it's so important tool by itself that we can separate it. There are other tools that you can think of that might, might think that they deserve a category by itself. For example, maybe knowledge base, etc. I can put it inside, I've decided to put it inside memory or tools. And then finally, maybe the most important is that the agent has an interface. It could be a user interface, like for a developer, or what Toran talked about right now, a user interface for anyone, basically having a mobile app or a web app. But it could also be an interface to another agent, right? So this is the most simple like diagram I could put in on a slide. Does it make sense? Like I think you asked about it before. You were good?
Yeah.
Okay, cool. Now, I want to talk about a specific use case, which is software development. Using agents in software development. First, I want to tell you a personal story. So, I was a co-founder and CTO in a startup called Visually that was acquired by Alibaba, and I opened Alibaba offices in Israel. And in Alibaba, you're really pushed, although it's a corporate, it's a really, in my opinion, an amazing one, you're pushed to develop really fast. Like they're try to keep the startup environment and culture, like change is the only constant, is the theme there. And we're pushed really fast we're pushed to develop really fast. And then one of the teams one day pushed to production something related to one of the e-commerce app, and basically turned blank one of the main areas for 1 minute until that was discovered, and that cost like $10 million or so. And so that, like, at that point when I'm thinking about it, like, I mean, like, it's very important that we could develop fast, but at the same time we probably need to do that with confidence, right? So I think like AI could help you develop fast, but also with confidence. And that is part of that. Remember the story, because I think it has a lot influencing the future that I'm going to show you, that how I see the intelligent software development future going to look like. So first, let's talk about software development process Gen 1.0. It's not software development 1.0, rather the process 1.0. Okay, so I think like traditionally or commonly, what we do basically we write some spec. It could be, if you're a backend developer, maybe it's some ticket or document or whimsical or whatever. If you are a front end, maybe it's a Figma or anything like that. And then usually what you do is from there go directly to implementation. Maybe you break it down to another dev ticket or so, right? But then you go to an implementation because you're being pushed to develop fast. And the next important thing is the code. And after you do that, if you have enough time, then you also write some tests in order to verify that what you developed is working like you meant to. And on the y-axis, you see executable, like spec, for example, is not executable until today. We'll talk about it. And code is as executable, and test is somewhere in the middle. Like it's executable, but it's not application code, right? And then the x-axis is time, like how usually you would develop things a long time. Okay, so I think this is a classical common way to develop. Do you agree? Okay, cool. And I think sorry, and yeah, one more thing to add here is that right now, although there are really cool dev tools that already exist, such as GitHub Copilot or any other tool that you're using. I didn't know if I start naming other startups, if I will be called out that I forgot one or so. So I'll use only, but they're really cool startup doing dev tools with AI. I think like they're fit inside this paradigm of Gen 1.0, but it does jump to Gen 2.0 with assistance. Okay, like you have an assistant for code completion, for example, Copilot, right? And maybe there is assistant or not out there for helping you to do specification, etc. And then the question is like, is there an ideal way to do it otherwise? So I'll just for the sake of the conversation, I would say that some people would say that maybe the ideal way is TDD. Um, Now I'll raise hands if you agree, if you don't agree to it. Okay, so for those online, most people do not agree that TDD is the way to go, and I think like there's many reasons why not, and one of them is that it's really hard to practice. We're missing tools to do that, and there are many others. By the way, I removed the time axis because now it's like done with the errors themselves. Okay. So the question is this ideal way to go? Maybe yes, maybe not. How I think about it, how we think about it, at least at Codium, is that you should actually be able to do it any way you want. Okay, AI could help us to do it any way you want. You could start from the spec, you can start from the implementation, you can start from the test, and then there will be agents that will help you to complete all others. I guess you're all familiar with the dry concept, where you don't want to repeat yourself with code. So why do we want to repeat yourself with spec or tests and code? And I think like there is some redundancy, but it's not totally redundant. Okay, because spec is not code. When you work on spec, you want to define what you want to do, but it's not as detailed as code, because if it is detailed as code, it's code, right? But you do want to start with some specification. Also test, without a test, you cannot really verify that the spec and implement code is actually fits. But there is a lot of redundancy there. So what we think is that basically with AI agents, eventually you would be able to start wherever you want, and the AI agent will help you to continue from there. Here is an example of some things that you can do already today with AI agents. This is the future, and it depicts a case where agents, like at least like I could think like agents are equal. Like we're talking about super agents with agents or agent swarm the swarm of agents that are similar. They're not specific. They're generic. And specifically, what I think is that we will have designated specialized agents that are really good in doing a different task. And this could be because they have different integration, even into different software, to Jira, to your production, to your app running in production, etc. So we'll have specialized agents. And actually, what you see here are like agents that you can already find. For example, in CodiumAI, you can find already a few of these agents that I'm showing here. That is going to demo like my partner is going to demo like in 2 minutes, and you will see like agents also helping you, or if you want like capabilities helping you, because it's not a fully autonomous agent right now. So capabilities helping you closing, like having tests and improving the tests, like closing the pipeline, closing a feedback loop. I'm jumping now to something else. To summarize, so far, I think software development is an amazing use case for development of agents, and you can think about it like agent helping you to take the dry concept to the extreme, aligning between the specification, code, and test, and then we believe that these agents will be specialized. And I think like one of the things we're going to do in the hackathon is try to create a few of these agents, use AutoGPT for some of these processes. For example, a reviewer, automated PR code review is meant to verify that the code is according to some specification, to some definition, or to some best practice, which I also call the spec, because spec could have a line of here's our best practices. Now make sure that this PR is according to the best practice. So that's the point. And I want to jump to something else, which puts some, like I want to explain why I think like all of these three are important. So I hope it's clear why we think spec is important, and it's part of it what you asked before, David, right? Like a spec is one of the places where a human can ask what they want from the agent. So I hope like explaining why spec is important is clear. I don't need to explain it, right? And why code is important also clear, right? Because this is what we want eventually. And now I want to explain why I think like tests will not disappear so easily. They might change their form and what it means. Like I don't think they will necessarily be called tests, but something that verifies that spec and implementation works as expected will exist. So let's talk about GPT-4. This is a figure that was published by OpenAI themselves, and they show like the amazing improvement between GPT 3.5 to 4 on different tasks, and some of the tasks like they reach to a level where they pass exams and maybe better than the average professional, which is amazing. But I noticed that, and I think many others noticed that on the Code Force rating, which is a competition related to developers, like for programmers, they reached a fifth percentile from the bottom. And why? Like GPT-4 is amazing in coding. It doesn't make sense because we use it every day, right? In one way or another, or some other LLM. Okay, maybe you use like other startup product and it works well for you, right? For programming. And GPT-4 is probably as good, if not better, from others. So how come this is the score? Okay, so I'm gonna try answering that. So here we see AlphaCode system, and they reached the 54 percentile, much better than the bottom 5 percentile. And the question is why? I'll explain a bit. What you see here on the left is like how the competition looks like. Sorry if it's a bit not zoom. I'm not zooming in. I don't want to ruin right now the presentation. But you see on the top, on the left, on the top, you see a natural language description of a problem, like a spec. Okay, on the bottom left, you see the code implementation. And they brag about it, why it's good, and they have all the reasoning to brag. It really works. They reach 54 percentile. And on the bottom right, you see their diagram. I'm not going to dive into it, but basically, like almost the entire solution here is like training, is about creating an LLM, creating a code generation API, okay? Like they take the GitHub data, they actually fine tune it for the specific case, which should be even better for the specific problem solution, question answering like data set. And then for each problem in the competition, they use this large language model to create not one solution, but actually create 10,000 solutions, sometimes less, sometimes even much more. And then they use another machine learning based solution to verify the code. So probably a lot of those solutions that were given like out of the 10,000 solution, I think maybe many of them are actually not so bad. Like a developer could take it and tweak it to make it useful and solve the problem. But this tweaking involves a lot of intelligence that we're so surprised by the amazing result we get from the LLM, but a small tweaking that we do is actually what makes the code work. And if you really try to automate this process, then most solutions do not work. The past 10, I'm talking about, actually drops underneath GPT-4 1. So in order to reach to their amazing achievement of 54 percentile, they add another part here on the right that actually automatically verifies does the solution fits for the spec. Is the code and spec are in fit? And I think this is actually like the competition is 101 programs. They're like CS 101, like bubble sort, a bit more complicated than that, but not much more. If you think of real world code, then this is probably even more important, okay? So basically, the agent that we're building right now, not open sourced, but it's basically like a working product, somewhat similar to small dev, but inside your ID, like Swix is here with us if anyone is online. So some working inside your ID, and we're going to show a demo. What we're trying to create is that code integrity agent, that specific agent that maybe could work with other agents as well, that focus on having 0 bugs. Like if there's those company that try to reach 0 emission or so, we want to clean the internet from bugs and reach 0 bugs. That's what we're trying to do. Okay, cool. It's time for a demo, and then we'll move to Q&A.
So hi everyone, I'm Dedi. I'm the Chief Product Officer of CodiumAI. I'm really excited to demo this. I think the idea is to really have you guys try out and use it as much as you can over the next couple of days, today during the workshop and during the actual hackathon. We'd love to get feedback. So that will be awesome. Hopefully it will be valuable also for you guys. So I'm just gonna try to exit this. So you can find it by just searching the marketplace on VS Code. We launched it 2 months ago. We have now 35K downloads on VS Code. We also have another 15K in the JetBrains marketplace and a few thousand of active users, weekly active users. So I'll show here an example. So I have here a Python implementation of a bank account. So it's a class that implements a bank account, and above it I have this little link to run CodiumAI on it. So I click on that, and then Codium opens up inside the IDE. The first thing that I get is the code analysis section that shows a textual spec of the code, and then I'm starting to get tests in this tab. So it basically tries to cover lots of different cases, so happy path, edge cases, all kinds of cases. I can interact with it, I can suggest changes, essentially kind of chat with it. I can also run the tests. So I'm going to click here on that. Actually, I'm going to redo this because I want to demonstrate something. So we'll just do this again. Bear with me. So yeah, code analysis again, that's just the textual description, and then test starting to stream. From some reason, it's a bit of a different test here. Let's see what's going on. Okay, so some tests you can see pass and some fail. On a fail test, I can hit the fix test button, and I'll do that for a couple of different tests. And what happens when I do that, the model is actually trying to figure out where is the issue. So it could be in the code or in the test. And if it was a problem in the test, it will just fix the test right away. And it will show me what was fixed in the test. And if it was in the code, it will tell me that there is a possible bug in the code. So let's look at that. It actually tells me what is the issue. So it looks like in the deposit method, I put a minus here instead of a plus. So it's actually deducting the amount instead of adding to it. So in the same way that I did before, now I can actually try to fix the code. So I'm just going to hit fix code. And it's going to prepare a code fix for that. And I can review that. Pretty straightforward in this case. And apply it to my code. And after I do that, I can basically rerun the tests and then see that the test actually that test actually passed. I think it was this one. Yeah. So that's a common. That was just like a very simple, typical use case. But now let's do something a bit more complex. A new cool capability that we just added is the ability to take into account the git diff. So what I'm going to do is I'm going to add some code in here. And I'm going to do add a new method like this, can withdraw, and I'm going to change the commission rate. So I save this. And now I can turn on this focus on code changes, this toggle. I'll turn it on. And let's regenerate the tests. So the idea here is to really help with the flow of the development. So as we make changes, sometimes we want to test and we want to focus on those changes. So in the code analysis section, I already see the git diff section. It actually tells me what actually happened. So I added the new method, changed the commission rate, and now all the tests that I get are going to be focused on that. And for each test, I can see how is it related to the diff. So this one will actually checks that this can withdraw method works appropriately in the kind of happy path case, and then it checks that it returns false if I try to withdraw more amount than I have in the balance, and so on and so forth. And then this one's just checking the commission, and of course I can run this test and see that they're actually passing. Finally, what I can do is I can open the test in a file, so I can then save this file and use it in my repository. One last thing that I want to show before I open up for questions. There's a code suggestions section that basically gives general suggestions for improvement. So this can be performance related, modularity, best practices, all kinds of suggestions that you can just kind of choose and apply to your code. And this is it. So love to hear if there are any questions.
It could be any question also
Anything.
about the previous section or whatever.
That demo is really, really cool. That's really impressive. I guess I'd be kind of curious. Are you guys running all of this with GPT-4 then? And
You want to answer?
So
I think you need to take the microphone or?
Yeah, so we use a combination of GPT 3.5 and GPT-4. Depends on the use case that we're trying to solve. We will use different models. So, for example, to create the suggestions, we actually have to use GPT-4 because otherwise it's not going to create good enough suggestions. But then to actually generate the code, we will use GPT 3.5. Mostly the trade-off is latency, right? If you use GPT-4 for everything, it's just going to take forever. Yeah.
one other question. Sorry, no.
You want to?
I'm just curious, like, it doesn't seem, it's awesome that I can install this and use it in VS Code, but it doesn't seem like it would be economically sustainable from a OpenAI token usage perspective. Could you expand a little bit on like how you plan on dealing with that long term, I guess?
I can take it. Do you hear me as well? Or okay, so two things. First, we are trying to be really efficient in how we call LLM models in general, and we are relatively open in the sense that we're trying to share as much as we can. Like, it just take time to write a good blog post, but we share how we do that in our blog post. Having said that, eventually the way we plan to do it is have a free tier for developers, and then work with enterprise, and that works well. I mean, like, we're not the first company doing that playbook.
Yeah, absolutely.
Is it like bring your own key?
No. So you don't need to bring your own key. You can just
Yeah, we
use
could just repeat the
CodiumAI.
question, I guess.
Yeah. So you don't need to bring your own key in this case.
Can you, if you want to? Or does it have to be
No, it runs on, like, you actually sign in, so you sign up for an account, like when you first downloaded it, and then it's all on us, basically.
There's a reason for that, like a few reasons. One of them is that it's the algorithm in our backend, like mostly, some of them in the front end, they do a lot. It's not like I would say that LLM part of the tech value here is 50%. I'm choosing this number intentionally. Like, without the LLM, this would not be possible. But there's a lot of engineering that's happening there. Part of it is the how we call it before, the agent engineers. No, you had a better.
autonomous agent?
Yeah. Part of it is the autonomous agent engineering, like a fancy word for prompt engineering and the tooling around it. But part of it is related to best practices related to testing and like the techniques that exist since the Greek times, like mutation testing and things like that. They're like important here. So it's not like a direct call from the ID extension to the APIs.
Yeah.
I have a question about the AutoGPT and future of plugins. So getting like the level of abstraction correct is a very tricky problem in general. And with AutoGPT wanting to both have the developer-centric way of interacting and then also building a UI layer, you're going to have this like very tricky how much you expose, how much you don't expose. I'm curious like how you're thinking about that, and then especially in relation to plugins. So if I build a plugin, do I need to build both like the code-centric way for making the plugin as well as like the low-code, no-code way that would work in the UI and interface? It'd be interesting to hear how you're thinking through this.
Yeah, Toran is with us.
Did you hear the
Sorry,
question,
that didn't come through super clearly on my end. I got the gist, but I would like to get the specifics.
You want to turn this off, and I think it would be good if it will be directly from him.
Okay.
It's a good one, so I think it's worth wasting another half a minute.
Yeah, yeah. Oh,
Yeah,
Can you hear it now?
Toran, can you hear me okay?
I hear you, yeah.
Yeah. So the question is about getting the level of abstraction correct as it relates to building the no-code way of interacting with AutoGPT, as well as the developer-centric way of interacting with AutoGPT. So I'm generally curious on your thoughts of how you're thinking about that, and especially with respect to plugins, right? So if I go and I build a plugin, do I also need to build the UI and the layer on top of it to interact with the web UI for all users, or can I just build the portion that assumes developers would work with installing my plugin? So it'd be great to get your thoughts on this paradigm.
Yeah, I mean, except for maybe some edge cases we've not thought through yet, then largely you would never have to build any sort of UI. You're really just making the tool on the computer that the agent can use, right? So if it's like, say you are Twitter and you want to provide agent access to Twitter, then you build a plugin that uses the Twitter API, and it makes certain commands available to the agent, like post to Twitter, check notifications, send message, and then the agent decides what to do with those tools.
Thanks.
I'm not sure whether I can follow that up. I'll try. So I've been working on small developer the past week or so. The weird thing that I ran into is that I think, and I also have studied the AutoGPT code and the Baby AGI code. The weird thing that I ran into, which I thought you hinted at in your presentation, but you didn't touch on, which is we know how to improve the quality. Just spend more cycles, right? Like spend more, like ask it to think step by steps, or to generate a million different variations, the same thing, and then pick from the best. We're not doing any of this, right? All of us are just one-shotting the code and then just running with it. And I don't know how to do that economically, right? Like literally I can just say, all right, do 5 replications of this, of this thing that you're trying to generate and pick the best. Or do 100,000 replications and pick the best. But I like that doesn't seem scalable, and the only way that I can think of is to like fine tune on something. Like, shouldn't this be a research effort or that we should do? I don't know, just as a community.
Yeah,
I guess both of you can answer that.
Yeah, I mean, there's obviously infinite different ways to answer that question because it's all about implementation. But zero-shotting something 100 times and picking the best result is probably still a very inefficient way to use something. Whereas, you could probably have such a better result by two-shotting something and say, write me this piece of code and then say, what's wrong with this piece of code? Fix it, And that can be 2 different zero-shot calls. Sometimes that's actually a lot better. But doing something like that, fine-tuning on loads of data will probably be amazing. I'm not an expert on that. But so much can be done through more than just multiple shotting, chaining together multiple zero-shot calls. I think that's a very interesting area.
Yeah, there's some. Oh, yeah, there's some papers on recursive criticism and improvement.
Exactly.
Yeah, all those techniques, right? We're just not using any of them. It's absurd. Like we could be so much better, but it would be 5 to 10 times slower because we're doing this in sequence rather than parallel, right?
Mhm.
There's just no free lunch here. Like either we just pay a lot of money or pay a lot of time.
Can I take it?
Yeah.
Do you hear me, Toran?
Yep.
Okay, cool. So the way we see it is that we want to automate the processes, but we still want the developers to be the driver, at least on the specification part. I'll explain. Sometimes if some piece of code doesn't work, it could be because something is not configured well, something like, let's put a cluster of problems that are basically something bad in the code that, for example, some numbers inaccurate, you do a plus or minus, or that it's relatively clear. You don't need the developer input. But some problems are in the question of what is the intent of the developer, what is it trying to do, and I think like then you need to have some input, and the input can come from a few places. It could come from the developer. It could come from some specification in somewhere else, like on Jira. It could come from staging environment or production environment where you see like some piece of data running through the software, and you can extract some information from there. Let me try to explain. I think like in all the cool videos, like in Toran video, really awesome, and in Agora, like I think like inspired a lot of us. Then there's basic math, independent code there, and also in your example, where it's a bit more complicated. It's like building an extension. Then it's still like you would expect. You expect many. You're okay with different variation of how it comes out, and probably you also like played a bit with some of the decision. But now, if you're talking about companies' code or real world code, then I think like you need much more data for the machine, for the agent, to make decision. It could be from the developer, like I mentioned. It could be some like from Figma. It could be from other places. So finally, I'm getting to answer you. I think like we could use these React. I saw today, instead of chain of thought, like tree of thoughts, which is what you're talking about, like running on various chains of thoughts and trying to choose the best one. Like you're asking about one program, but we can actually execute a program and refine it. So like it's tree of thoughts that creates a bunch of options. We can do that for a cluster of problems. Like if there is something that was not implemented well, that is just engineering, but no decision needs to be made about what is actually we're intended to do. And so I think this could, your suggestion, like having a lot of compute could help there. And I think there's research that can be done to prune that. The similar way of how AlphaGo was developed, etc., or chess. And originally was really like time consuming, but they found out different reinforcement learning techniques that could prune and choose like efficient way. But there are some problems that we could not really fully automate, and we can improve the automation by collecting data from different places from the developer, from something the developer wrote previously, from production, etc. Toran, you want to add something?
No? Yeah, I think you answered that very well.
Okay, we're more than an hour. If somebody have if you have a question that you would like us to ask online, I think it's a good time for the last question. Otherwise, we're gonna I guess open the beers and before we start coding or something like. We have also wine. I'm not sure. I need to check. Any other question? So maybe take the mic.
Yeah, I just had a question about the if you had any tools that worked with. How's my audio? All right. I had a question about if you have any tools that work with multiple files. So I see a lot of demos that do AI working with one file, giving suggestion for one class, or changing a method, or writing tests for one class. It's challenging to get an agent that's aware of a full file tree and comprehends complex relationships like abstract classes or shared code bases. There's some approaches to do this. I think maybe you've thought about it. I'd like to hear maybe if you have any comments on it.
Yeah. Do you want me to take this question? I feel like we could both probably answer it.
Yeah, Daddy can start.
Yeah,
and
I'm
then,
gonna.
I'm very happy to hear it.
I'm gonna try.
Yeah. Good.
Right now in CodiumAI, like one of the biggest challenges that we believe that we're really helping developers solve is exactly that. So when you generate tests for a given class or function, it collects all the relevant context from your repository. So it actually looks at the imports and it brings them in, and it looks at what this class is calling and anything that is calling this class. And there's a whole process, like kind of a pre-processing step that collects everything, prunes it, tries to fit it into the context window, to the number of tokens that it can actually go into the model. So it already does that. But it's the way we work today, it's still in the context of a certain component. So you still have to click the link of a certain class or function, or you can kind of select code and right click, and then you can kind of pick and choose a code snippet, still in a single file. It will still bring the relevant context to it. We are trying to experiment, and we're thinking of ways to do to generate tests for example, like a React application that you're trying to test, like this button, okay? You're trying to test, it's not like a specific code component. So we are working on ideas, we're ideating on things of how can we do things that span like that. Hopefully it answers. Do you want to add?
Maybe Toran?
Yep. Yeah, so I've played about with this a lot. It's the ultimate question, really, isn't it? You know, if an AI can write an entire, limitless code base, that's the end of tech. It's the end of programming. But yeah, I mean, something I've discovered in working on this is there's actually two problems. One is that, how do you know when you're working on a code base? How do you know what variable is in a different file? How do you know like what this function in a different file returns, or what input it needs? And this is something that is built into your IDE. You can click on links in your code and move through it. So this is kind of a solved problem. But the real question is, if you're making a program which from scratch, like the agent is writing an entire code base, how does it know what to call in the main file? When it's calling like the graphics renderer, how does it know what variables to give? And to answer this question, I mean, it's a huge question, but to answer this question, you've got to think of like, how do we do that? How does a programmer start writing the main file? Maybe you call a function you've not written yet, and the way you can do this is because you have this high-level overview of the code base in your head. It's the same when you're working on a code base that's already being worked on a bit, and so that's the information you need to get to the agent or to the language model. It's not just the task, not just the specific requirements, but it's the high-level overview.
Great. So I think we had I enjoyed it really much, the conversation and all the questions. I hope you did as well. Like according to what I saw from the audience, like you're really engaged, and we have thumbs up. So I hope in the audience as well. And I think from here we'll take it offline and we'll start hacking and testing and coding and solving challenges, challenge-driven development. Thanks, Toran, and I hope to see you someday soon in real life.
Yep.
And you're having a lot of people here waving hello to you, and it was really awesome to see you live.
Yeah, great to see you all virtually.
Cool. Great. Bye, Toran.
Bye.
Okay, so I think from here, we're offline, right? I think from here is like, we had a plan, but maybe we can discuss it. Like, how do you like to